Hi, welcome again. My next installment of your quiz test review. Now, I gave a quiz today, as you all know. And in one of my classes, I said, for extra credit, draw the free body diagram for a person skiing down a mountain, given a certain inclination. We'll call it theta. Okay? We'll call it theta. All right? Now, what I want to do right now is I want to do a free body diagram of someone skiing down a mountain. Now, they were done actually very well. I was pleasantly surprised. But there was definitely something that my students did that needed to be clarified. All right? So let me begin. A skier of some mass is coming down the mountain. The mountain is represented by an inclined plane. The skier is the box. And the angle is theta. So let me draw in the various forces and vectors that will be important in formulating the free body diagram. The first thing I like to do is I like to draw in the weight, the normal, and the FP, or said another way, would be the weight that's perpendicular to the plane. This is the plane. The weight that's parallel with the plane, perpendicular, parallel, right? Okay? So let me start off with those three vectors. Now, how do you do that? This is the problem students had. The weight is straight down to the ground, straight. That's actually going to be the hypotenuse. And whatever it is, it's always straight down, all right? So, that's going to be straight down. Now, I'm going to exaggerate it a little bit, and it may not be perfect. I'm doing it freehand, but it's going to be close enough to understand. All right, so FW, straight down, every time, and that forms the hypotenuse. That's key. The next one is going to be, I'll draw in the normal. Now, the normal is that portion of the weight that is perpendicular to the plane. Right there. The plane, perpendicular. Right? Forms a 90-degree angle right there. Okay? So I'm going to draw that, and I'm going to draw an exaggerated version of that. All right? Again, it's going to be freehand, but it'll be okay. Straight down. It's going to be perpendicular to the plane. Okay. The next one I'm going to draw is going to be parallel with the plane. Parallel. Here's the plane. That's parallel. So I'm going to go down to here. Okay? Now, if this is parallel and that's perpendicular, these and this are going to be at 90-degree angles to one another. So, parallel, Okay? So far so good? Now, I can erase that. I'll make that a vector. Right? Easy. Straight down. Perpendicular to the plane. Parallel with the plane. Now, opposite the hypotenuse is always the 90-degree angle, the right angle, right? Largest angle, largest side. Okay. Okay? So there's my right angle. Perpendicular, parallel, so that's got to form a right angle. So that's it. And that's a little bit difficult. People want to draw a isosceles triangle. But practice. Take some practice. Now, let's continue, okay? Now, be aware that the normal, that's negative. Okay? Right? That's Fn, that's the positive. All right? That's going to be, the normal is always up. Remember? Horizontally, weight down, normal up. Okay? Easy? Now I've got to draw in, I have Fp, but I want to attach it. Key. Very key. If there's a force that is touching the box, you've got to make sure it's touching the box. So let me erase this. Get that out of the way. I'll get that out of the way. We know that's the plane. Okay. So my Fp is going to be down. Okay. So I can make that positive. Okay? I'll draw in another vector. I like to draw this one in. That's the motion. I like to draw that one in. Tells you where the motion's going. Excuse me. If the motion is down, motion's positive. Fp is down, Fp is positive. Friction, negative. Okay? Now there are several other forces that aren't forces. There's the net force, which is actually a sum of two forces, so that's not a force that's touching the box. So you put that like that. Okay, negative. Down. Okay. Another vector is going to be acceleration. I'm going to accelerate downwards. That's positive acceleration. Easy? Now, given time and v equals at, v is also another vector, and that's going down as well. And you're going to have a positive velocity. That's it. That's your free body diagram. You start with this. Now look at this. If that is not similar to that, you're doing something wrong. So that, if I take this and I flip it like that, it's the same triangle. So that's got to have that is that. Okay? That is that. So you're going to flip this around like this. Okay? This is this. Got it? So that's the first thing you do. You make that right triangle. And then you have to interpret the physics. Interpret the physics. Okay? End of part, whatever it is. Have a great day. You know what? I'm done for the day. I'll see you in the morning. Have a great night. Tenga buen sueños, and see you tomorrow. Goodbye.